Hello students, in today's class we learn the derivations of equations of motion. So equations of motion. Then four equations of motion. Many people, some will write only three, but there are four equations of motion. They are number one, V equal to U plus A. Number 2, S equal to ut plus half at square. Number 3, V square minus U square equal to 2as. Number 4, Sn equal to U plus A into N minus half. So these are four equations of motion. Observing these four equations of motion, the terms in it we can find U for initial velocity. U is for initial velocity and V is for final velocity, and where A is acceleration, T is for time. This is going to represent a period of time, and S is distance. S is distance, and finally the last word we have is N. N is also time, but this is not period, this is point of time. So what's the difference between period and a point? Period means the time it measures at between two regular intervals. But N is a time that represents at an interval. So what's this? In simple terms I will explain. 15 seconds, 15th second. T, 15 seconds. N, 15th second. So what do you understand from these two words, 15 seconds, 15th second? See, 15 seconds means the time has been counted beginning from 0 onwards. So from 0 interval to 15th interval, all seconds have been counted, total 15 seconds. But 15th second means 0 to 14 seconds have not been measured. Only the 15th second interval is measured. So that is the difference between period of time and point of time. So in equations of motion, to represent a period of time, the symbolic notation T, point of time, the symbolic notation is N. Okay, let us have the derivations. So equation 1 derivation is very easy. From the definition of acceleration, we have explained as change in velocity with respect to time. If the change in velocity happens in a moving object from one speed to one velocity to another velocity, from the where change begins, it is called initial velocity. We know that at the where the change ends is a final velocity. So change in velocity is the difference of V minus U. Similarly, the time interval will be T2 minus T1, that can be taken as T. So t2 minus t1 is taken as t, then a is equal to v minus u by t. T is transposing a into t is equal to v minus u. Exchanging the terms, v minus u is equal to at minus u into RHS will become plus u. Then we got v is equal to u plus at. So once again, the definition of acceleration, change in velocity with respect to time. So when object changes its velocity from one point to another point, change beginning velocity, initial velocity, finishing velocity, final velocity, time intervals t1 and t2. So what's the change in velocity happens? It is v minus u. Change in time t2 minus t1. Let us take that v minus u by t2 minus t1 by t. Then a is equal to v minus u by t, and derivating it will bring v equal to u plus at, first equation of motion. Now take on second equation of motion. In second equation of motion, we are going to take a step from previous equation, that is we better choose we don't go that way. We choose alternate method. Another method is the definition of velocity. Velocity is the displacement covered with respect to time. Then t is transposed to LHS. We get v into t is equal to s, and where s equal to v into t. See, this equation is actually applicable for uniform motion, but equations of motion represents non-uniform motion. That's why they contain acceleration too. So when this equation is modified to non-uniform motion, s is equal to, distance remains the same, but the velocity in non-uniform motion, we have initial velocity and final velocity. So we need to take the average of initial velocity and final velocity as the velocity into time. Then s is equal to u plus v. From equation 1, we use u plus at. So here we substitute u plus at by 2 into t. Now s equal to u plus u, 2u plus at by 2 into t. Then multiplication with the t is 2ut plus at into t, at square by 2. Resolving into fractions, s equal to 2ut by 2 plus at square by 2. 2 cancels each other, then s equal to ut plus half at square. It's going to be second equation of motion. And the third equation is very easy. We can take equation 1 to find third. Equation 1. To get the third, equation 1 is v equal to u plus at. So make it square on both sides. Square on both sides. See that? LH is V square, RH is U plus AT whole square. Then V square is equal to, this is A plus B whole square. According to that, A square plus 2AB means 2 into A into B plus B square AD whole square. Now V square equal to U square plus, the product is 2UAT plus this product AT whole square is A square T square. So U square transposing to LHS, V square minus U square is equal to 2UAT plus A square T square. So we have got LHS, V square minus U square. To get RHS, what are we going to do? From these terms, I am going to common 2 and A. From the both terms 2 and A, I am going to get it common. 2 and A. 2A when common, what's left here? U and T. Plus, there is actually no 2, but we have common. What happens when an unknown is, when an existing element is common, we get its reciprocal. And from A square, A is common, so one more A is left, T square. Now see inside the bracket, UT plus half AT square. From equation 2, UT plus half AT square will be S. Then V square minus U square equal to 2AS. This is the third equation of motion. Okay. Now final one, complicated one, fourth equation of motion. So it will, here we need to take some attention. In fourth equation of motion, we observe, we make some observation by assuming an object which was at A, starting with an initial velocity u, producing an uniform acceleration A, and reaching to a destination C, and the total distance it traveled from A to C, let it be S, and the time taken for the journey is T. So with this observation, the total distance from A to C it has covered is S equal to UT plus half AT square according to second equation of motion. Let this be equation 1. Okay, the time to travel from A to C is T seconds. Just 1 second before, we just assume the same object was at B. 1 second, which second that is? Definitely that is last second. The last second, here we need to take observations carefully. Say for example, if any journey is 15 seconds, what will be the last second means? What we say? The last 1 second will be 15th second, and before we have 14 seconds. Okay. Similarly here, the total journey is going to have t seconds. The time we are going to assume n seconds for our easy solution. For our easy solution, I will take the total time t is n seconds. Then 1 second before means, see we said 15 seconds. 1 second before means 14 seconds. How we got? From 15 seconds we have removed 1 second. Here we have total n seconds. 1 second before means we have n minus 1 seconds. In this n minus 1 seconds from A to B, it has traveled a distance of yes n minus 1. Then this is the only 1 second is left, that is nth second, and the distance it covered here is Sn. This Sn distance, whenever we calculate, we find fourth equation of motion. So first of all, we take how much distance it has covered to travel from A to B, because A to C we have already calculated. Now we calculate from A to B, the total distance is n minus 1 is from the second equation of motion ut. Time this time is n minus 1 seconds of acceleration remains the same, and time is n minus 1 second, and it is equation 2. We have equation 1 and equation 2. So this is equation 1 is AC distance, total distance. Equation 2 is AB distance from A to B. But to get the solution, what we actually required? B to C, BC. How can we get BC? Is AC minus AB. So BC distance is S1, we need it. AC distance is S. AB distance is Sn minus 1. And S distance is Un plus half An square minus of his distance is U into n minus 1 plus half A into n minus 1 whole square. Then Sn equal to Un plus half An square, that is minus of U into n minus 1 minus of half A into n minus 1 whole square means n square minus 2n plus 1. Okay? N square. Okay, I think I did not get it in the video. I will repeat it. The distance is here, minus of means minus U into n minus 1, this is minus half A, and n minus 1 whole square according to A minus B whole square, A square minus 2AB plus B square. 2AB means 2 into 1, n into 1, 2n, 1 square is 1. Now Sn is equal to Un plus half An square, the product is minus Un plus U, this product is minus half An square, minus half minus plus 2 get cancelled, plus An, minus of plus is minus, half A into 1 is half A, and here Un minus Un cancels each other, plus of An square minus of An square cancels each other, then Sn equal to U plus An minus half A. So after the cancellation, what it left? Sn equal to U plus An minus half A, and A is common in here, it leaves inside the bracket n minus half. This is equation number 4. Okay, that's the derivations of fourth equations of motion. Okay.